Digital image processing. So the interest in digital image processing is arrived due to two application areas. The first one is improvement of picture information for human interpretation. Okay, whenever human sees the image, that the image should be improved. The quality of the image should be improved. That is the first area due to which image processing is introduced. And the second area is that the processing of image data for storing, transmission, and representation for autonomous machine perception. Okay. So what is that here? Whenever we are having the image data, so we will be storing the image data because in the internet, across the internet, we are storing the image data. Whenever we are storing the image data, the data should take less number of bytes. Okay. So less memory. So the storage requirement should be reduced and transmission should be taken care and these images should be represented properly for autonomous missions so that autonomous missions can act properly by understanding the images. Okay, these are the two application areas due to which image processing is introduced. First, we'll discuss what is digital image processing. An image may be defined as a two-dimensional function f of x comma y, where x and y are the spatial coordinates and f is the amplitude at those coordinates x comma y. And this f is called intensity or gray level of the image at that point. So xy and this intensity values here we have discussed xy and the intensity values f are if r are finite and if these are discrete quantities, then the image is called digital image. Okay. So the field of digital image processing refers to it is the processing of digital images by means of digital computer. So what is digital image processing? Digital image processing is nothing but processing the digital image by means of digital computer. A digital image is composed of finite number of elements, each of which have a particular location and the value. So if you just see the digital image will be like this here. It will be having finite number of elements. It will be having finite number of elements and each element will be having a particular location. There is a location corresponds to each and every element and the value corresponds to that. Okay. So these elements are called picture elements or image elements or pels and pixels. These are the different names are used to represent each and every element of the image. So usually pixels are used in most of the times in this course. Okay. So the here, if you see, the vision is the most advanced of our sensors. Okay. So in our sensors, which is the most advanced one is the vision only. So it is not surprising that images plays a single most important role in human perception. So the in the human perception, if you see the images play a very important role. Human can understand the images very easily compared to the voice and so in the human perception images play very important role. So here if you see the image human vision will be limited to only electromagnetic spectrum. It will be limited to only the visual band with the electromagnetic spectrum. Okay. So whereas the imaging missions whatever we are going to discuss will cover the entire electromagnetic spectrum ranging from gamma to radio waves. They operate on the images generated by the sources that humans are not accustomed to associated with the images. Okay. So this image processing will deal with all types of images which are covered in this EM spectrum. This includes what? Ultrasound, electron microscopy, computer generated images. All these are human is not accustomed with these type of images, whereas image processing will be able to deal with these type of images. Okay. So thus the digital image processing encompasses a wide and varied field of applications. That is why digital image processing will be having varied field of applications. It is having more number of applications. And here we'll discuss what are the three types of computerized process in continuum from image processing at one end to the computer vision at the other end. So what are the three types of processing methods we are going to discuss here? The first one is low-level process. The low-level process will involve primitive operations, the basic operations. So what are the primitive operations such as image reprocessing to reduce the noise, contrast enhancement, image sharpening. These are the image reprocessing. Okay, that will be involved in low-level processing. So a low-level process is characterized by of low-level process. What is the input and output? The input and output both are images. Okay. So middle level processing on images involve the tasks such as segmentation, description of those images to reduce them to a form suitable for computer processing. So here what is segmentation? We are partitioning the image. So we are getting the part of image which is most important. And after segmenting, we have to describe those objects which are segmented. So these objects should be described such that these are suitable for computer processing and classification of individual objects. So from this segmented image, we have to classify whether what is that type of image. Okay, so that will be done here. So in the classification, for example, if you take medical images, the tumor area will be segmented and it will be classified that it is a tumor area like that. So middle level process is characterized by the fact that its inputs generally are the images, but outputs of are attributes extracted from those images. Okay. So what are the attributes? Attributes are nothing but the edges, counters, identity of individual objects. Okay. So this will be the outputs, whereas the inputs are the images. Finally, we have high-level processing. High-level processing involves making sense of ensemble of recognized objects. Okay, so we will be taking the group of recognized objects as in image analysis. Okay, and the far end of the continuum performing the cognitive functions normally associated with the vision. Okay, so here what is that in high level processing will be doing? It is able to make the decisions based on the input data. Okay, so for example, if you take autonomous vehicle, so where the automatic driving vehicle will be driving the car by itself. Okay, what it will do, it is able to think by itself. Okay, so that comes under high level processing. Okay, so from the image data, whatever it is getting, it is able to think. That is called high level processing. Okay, so in low level processing, both input and output are the images, whereas in the middle level processing, the input is images, output are attributes of images, that is the edges, counters, okay, identification of individual objects, all this called attributes of the images. And in high level processing, the input will be the images, the output will be that the system is able to think by itself. Okay, it is able to take the decisions by the images, whichever it is getting as inputs, that is, whichever it is getting as inputs. That is called high level processing.